So, once again, welcome to all of you on my lecture series. And today I will be discussing the first part of lecture on probability distribution of random variables. So, before starting this lecture, I will be briefing you what are all the things that I will be discussing today. So, in this lecture, first of all, I will be discussing about the random variable. What are the random variables? And then I will be coming to the probability distribution. So, what are the probability distribution? What are the properties of probability distribution? What are the different types of probability distribution? And lastly, I will be starting today with the first probability distribution, that is binomial distribution. And in the coming lectures, that is in part 2, I will be discussing about the Poisson distribution, and in last part I will be discussing about the normal distribution. So let us start with the part 1. So first, what are the random variables? So a random variable is a rule. What is random variable? It is a rule. Just try to understand, because this probability distribution we have not studied earlier, so it is a bit tricky and you have to understand it very well. But since you have taken the basic concept of probability, it will not be a very tough nut to crack. So what is a random variable? It is a rule that assign numerical value. So this random variable is a rule which assign numerical value to observations or measurement. So whatever observations you are taking or whatever measurements you are taking, if you are assigning a numerical value to those measurements or observations, then those numerical values are known as random variable. So it is why it is called as random variable, because the number that is assigned to observation is numerical event which varies randomly. So what are the numbers that will be assigned? So the number that is assigned to the observation or measurement is a numerical event, and that assignment of number is random. That assignment of number is random. How it is random will be seen in next few slides. So just see this picture here. Suppose this is the coin, tossing of a coin. So if the tossing of a coin, as you know, it is having sample space of 2. What is sample space? I have already discussed. So the tossing of a coin is having 2 sample space. So if you want to assign, that means it is having 2 observations. And this 0 and 1, suppose if there is head, we are assigning it 0. And if there is tail, we are assigning it as 1. So this assignment of number, this numerical value, it is random. I may assign head as 1 and tail as 0. Then these kind of variable values are called as random variables. So random variable assignment of numerical values to these variables are random. That is why it is called as random variable. So the probability distribution of random variable may be the theoretical listing of outcomes. What are the outcomes? Head and tail. And probabilities which can be obtained from mathematical model. So these are the probability of these outcomes. That means probability of head and probability of tail. So this probability of this outcome it can be obtained by a mathematical model. So there may be certain models we have already studied when we were studying about the probability, that there are certain mathematical model which will explain what are the probability of happening of a particular event. So it can be obtained from a mathematical model representing a phenomena of interest. So simply you have to remember that a random variable is a numerical value. It is a rule which assigns the numerical value to sample space or a particular event that is obtained by as observation or measurement. And it is called as random because numerical value assigned randomly. And then these numerical values can be obtained from a mathematical model. So these are the basic thing about the random variable. Then there are certain types of random variable. What are the random variable? Random variables can be discrete or continuous. So I have already discussed what is discrete and what is continuous when I was discussing about the variable. So random variable can be discrete or continuous. The observed frequency distribution is based on observation and experiment. So we have already seen about the frequency distribution when I was discussing about the classification or grouping of data, where I have already discussed about the frequency distribution. So the observed frequency distribution is based on observation and experimentation. We are getting frequency distribution, we are doing frequency distribution when we are collecting some observation or when we are doing some experimentation. But there is another type of distribution which are based on previous experience. So for this we are not doing an experiment, but it is based on the previous experience or due to certain theoretical consideration. So what are the previous experience and what are the theoretical consideration? Before that, let me continue. Which can be deduced mathematically. This previous experience and theoretical consideration can be deduced mathematically are known as theoretical or probability distribution. So there are, first distribution is frequency distribution, which we are obtaining after observation or experimentation. But there is another kind of distribution which can be obtained by previous experience or due to certain theoretical consideration. And this theoretical consideration we can deduce it mathematically with certain mathematical formula. Example, tossing of a coin or rolling a dice. So tossing of a coin, we know with the previous experience that tossing of coin will always result in head or tail. There will not be any other event. There will be either head or tail. Similarly, if we roll a die, there is always possibility that the outcome or sample space will be 6. There will not be sample space of 7 or 10 or 20, because these are the things that we know from our past experience. So the value of a variable x is numerical event and thus it has some probability. Now this value of the variable, that means tossing a coin. If you are tossing a coin, you will get either head or tail. So this head or tail will have some probability associated with it because it is a numerical event. So now what is the probability distribution? What is probability distribution? So probability distribution, a table, graph or formula that shows that probability is called as probability distribution. So in the previous line we had studied the value of variable x is a numerical event and thus it has some probability. So whatever values, whatever events we are obtaining after tossing a coin or rolling a die or any such observation, there will be some probability, some kind of probability associated with it. So what is probability distribution? A table or graph or formula that shows that kind of probability is called as probability distribution of random variable. So in presenting the probability distribution, we use mathematical function as a model. So for knowing the probability distribution, that means what are the probability of these particular events? If it is head and tail, then what are the probability of head and tail? If it is 1, 2, 3, 4, 5, 6 in case of rolling a die, then what are the probability of 1, probability of 2, probability of 3, probability of 4, 5 and 6. So such kind of distribution is known as probability distribution. And how this probability distribution will be obtained? It will be obtained by mathematical function as a model. So now functions that represent a theoretical probability distribution of discrete value. So those functions that represent the probability distribution of discrete value, such functions are known as probability functions. Such functions For discrete value, such functions are known as probability function. Whereas if it is continuous variable, then it is called as probability density function. So we know there are two types of variables, continuous and discrete. So in case of discrete, this probability distribution is known as probability function, whereas in case of continuous variable, it is known as probability density function. Probability density function. Since it is continuous, that is why it is called a density. Now coming to the probability distribution. So with this brief idea about probability distribution, we will see what are the different types of probability distribution. So we have already discussed that there are two types of data, discrete and continuous. So in case of discrete data, there are two types of probability distribution, binomial distribution and Poisson distribution. Whereas in continuous type of variable, there is one distribution, that is normal distribution. So we will see one by one about these distributions. So first we will see the probability distribution of discrete variable, discrete random variable. It is constructed on discrete random variable. Okay. All possible outcomes are finite. For discrete random variable, all possible functions will be finite. What are the discrete random variable? Discrete random variable means tossing a coin. There are only two variables, two events, head or tail. In case of rolling a die, the events are 1, 2, 3, 4, 5, 6. So all possible outcomes are finite. There will not be unlimited outcomes. A random variable is said to be discrete when all the possible outcomes are countable. So in case of discrete variable, outcomes are countable, that is outcomes are finite. It is the explanation of the previous point only. An example of this kind of discrete random variables are tossing a coin, throwing a dice, drawing cards from pack of cards. Now we will see the actual binomial distribution. The first one under heading discrete probability distribution is the binomial distribution. So it was discovered by Swiss mathematician James Bernoulli. And that is why it is known as Bernoulli's distribution. So you have to remember the binomial distribution is also known as Bernoulli's distribution. There are many trials that have only two outcomes. So this type of distribution works only when there are only two outcomes. So, and there are a lot of events where there are only two outcomes. So the common example is tossing a coin. In tossing a coin, you are having only two outcomes, head or tail. And second example is sex of a newborn calf. It will be always male or female, only two possible outcomes. Then another condition is diseased condition, whether animal is diseased or healthy. So only two outcomes, diseased or healthy. So there are lot many events where you will observe only two outcomes. So all such two outcomes will be signified by binomial distribution. Such single trial are called binomial or Bernoulli's trial. Such single trial are known as binomial or Bernoulli's trial. Now, the binomial distribution can be defined as the probability distribution of discrete variable where there are only two possible outcomes. So we have already seen in each trial you will have only two possible outcomes. Whenever you are performing a trial, you will have only two possible outcomes. In this case, both of these outcomes are important, but you cannot say which one is less important or which one is more important. In case of binomial distribution, you cannot say which one is less important or which one is more important. Both the outcomes will have equal importance. Now, there are certain assumptions for binomial distribution. So, I think most of the points I have already discussed, but still I will be reading it. Each trial should have only two possible outcome. Only two possible outcome. Okay, that is success or failure. But don't go on this writing success or failure. With this, you cannot say whether success is more important or success is less important. Both these will have equal importance. Then the second one, the probability of success or failure should remain constant from trial to trial. Whenever you are performing a trial, probability of success or probability of failure will be equal. Success and failure should remain constant, whether it is equal or not, but it will remain constant. The events should be independent of each other. So if one event has happened, it will not affect the future happening of events. That means the events should be independent of each other. And the trial should be repeated for a fixed number of times. The n should be finite. So what it is telling, that trials should not be infinite. Trials should not be infinite. It should be for a finite number of times. That is n. N should be finite. So these are the assumptions for binomial distribution. We will see if the assumptions are violated. In the coming lectures, we will see if assumptions are violated, this binomial distribution will be converted into certain other kind of distributions. Now, the sample space in binomial distribution consists of only two elements. So we have already discussed there will be only two sample space. If we denote the probability of success as P, we denote probability of success as P and that of failure as Q. Then the probability of sample space, probability of the sample space will be in case of two trial. In case of two trial, if you are tossing two coin, then what will be the probability? Success failure and failure. Success failure and failure. And you can represent its probability as p square, 2pq and q square. Similarly, in three trial, if you are tossing three coin, so success failure and failure, and the probability will be pq, 3p square q, 3pq square and qq. So if you see this pattern, you yourself can say that this is following a certain kind of pattern, and this pattern is, what is this pattern? So this pattern is accomplished by this formula, this algebraic formula, p plus q raised to n. So where n is the sample size, that is number of trial or number of samples, and p is the probability of occurrence of first class. Occurrence of first class means success or failure, whatever you have assigned as a first class. Then q is the probability of occurrence of second class, that is success or failure. So this binomial distribution always follows p plus q raised to n, where n is the number of sample size or sample space. Now you can see, if we extend this p plus q raised to n from 1 to 4 event, then you can see this pattern. P plus q raised to 1 is equal to p plus q. P plus q raised to 2 is equal to p square plus 2pq plus q square. P plus q raised to 3 is equal to pq, 3pq square, and then 3pq square and q. Similarly, p plus q is raised to 4. So these are the expansion of the p plus q raised to n, if n varies from 1 to 4. Now based on this, we can say the coefficients. What are the coefficients? The number before the power of p and q. What are those numbers? So these numbers are these things. These number that are prior to p and q. These are the coefficient. Here coefficient is 1. These are the coefficients. So the coefficient, the number before the power of p and q express the number of ways a particular outcome is obtained, and these are known as binomial coefficient. So these are known as binomial coefficient. And if we arrange this binomial coefficient or from 1 to n, then we will be getting a binomial triangle, and this triangle is known as Pascal triangle. So we'll see in the next slide what is Pascal triangle. So just see this triangle carefully. So when the number of sample space is 0 or n is equal to 0, then the coefficient will be 1. Similarly, if it is 1, then coefficient will be 1, 1. Then it is 2, 1, 2, 1. That is p square plus 2pq plus q square. So coefficient is 2. Similarly, p square, 3p square q, then 3q square p and qq. So see, in this way we are getting this coefficient as Pascal triangle. So very easily we can form this Pascal triangle, and we can get idea about the coefficient or the number, what are the probabilities of different events if n is varying. Now how we will calculate the expected binomial frequencies. So what we can do, we can obtain the probability of either 0, 1, 2, 3 or up to r success from total number of trials. Suppose you are taking one trial. So what is the probability of getting success? That means what is the probability of getting favorable event? If it is 0, if your favorable event is 0, what will be the probability? So for getting probability, you can use this formula, that is probability of r, that is number of successes in n trial. So what is the probability of success that you have obtained in n trial? It will be NCR. NCR, it is the combination of r, that is number of success in n ways, into probability of successful event raised to r and q raised to n minus r. So you know the NCR, that is n combination with r, is equal to n factorial divided by r factorial into n minus r factorial into PR q into n minus q raised to n minus r. So we can expand this formula in this format. And what is the p? P is the probability of success in single trial. Then q is the 1 minus p. N is equal to number of trials, and r is the number of success in n trial. So what you have to do, actually the questions on this combination or finding the probability numerical problem, you will find very less numerical problem at the undergraduate level, but you should remember this formula. And there are few conceptual questions that will be asked in your examination related to this formula. So that we will see. Now just take one example simply to understand it in better way. Let us find the relative expected frequency of getting 0, 1, 2, 3, 4 head if a coin is tossed 4 times. Suppose you have tossed a coin 4 times. So what is the probability? What is the probability of getting 0, 1, 2, 3 and 4 heads? So the formula we have already seen, and now P is equal to first case. Simply we have taken this first case. First case means there is no head. You have tossed a coin 4 times and you did not get any head. So what will be the probability of that condition? So P under bracket no head is equal to 4 factorial, because R is equal to 4. R means number of trials. So 4 factorial divided by 0 factorial, that means 0 is the successful events. So 0 factorial into 4 minus 0 factorial. Similarly, Now, what is the probability of successful event? 1 by probability, you know, probability of getting head is 1 by 2, but the favorable event is here 0. So 1 by 2 raised to 0. Similarly, probability of getting Q is equal to 1 by 2, and on 1 by 2 raised to n minus r, that means 4 minus 0, that is 4. And if we will solve, we will get 0.625. Now, similarly, we can find it for 1 head, 2 head, 3 head, and 4 head. So, just see here. This is the another cases that I have calculated here directly. So, you can see in first it is 0.0625, next 0.25, 0.375, 0.25, 0.0625, and in addition, for probability of sample space, it will be 1. So this is the way how you are getting the probability of different events under binomial distribution. Now, this is the very important point for undergraduate student, that is to know the probability of binomial distribution. So what are the probability of binomial distribution? It is telling the sum of probabilities of 0, 1, 2, 3 up to n successful event or n successful event is unity. So all the events, if it is summed together, then probability will come 1. We have already seen in the last slide. So summation P into R is equal to summation PR is equal to 1. So this is very important property of binomial distribution. Similarly, the mean of binomial distribution is NP. This is the most frequently asked question in your examination, both in annual board examination as well as in your internal examination, and then also in competitive examination, and its variance is NPQ. So these points you have to remember. There is a certain derivation formula also, but it will not be wise for you to study those formula or those derivation at the undergraduate level. That is why you have to remember that mean of the binomial distribution is NP and its variance is NPQ. The quantity n and p are the parameters of the binomial distribution, and they determine the shape and location of distribution. So this also you have to remember that n and p are the parameters of binomial distribution, and these n and p decide the shape and location of this binomial distribution. Shape and location. Now the fourth one, for n trial, a binomial distribution consists of n plus 1 terms. N plus 1 terms. How n plus 1? You see here 0, 1, 2, 3, 4 up to n minus 1 and c and n. So these are terms 1, 2, 3 up to n and n minus 1 and n. So that is why total term is equal to n plus 1. For n trial, if you are performing entire trial, binomial distribution consists of n plus 1 terms. Next is, if p is equal to q, that is 1 by 2, the distribution is symmetrical. In case of binomial distribution, if p and q are having equal probability, that is 1 by 2, then distribution is symmetrical, and the expected frequency on either side of the central value will be identical. Symmetrical means it is quite obvious that expected frequency on either side of the central value will be identical. Sixth one, a binomial distribution is positively skewed. It is skewed positively when if probability for a particular event P will be less than 1 by 2, and it is negatively associated if P is greater than 1 by 2. So this also you have to remember when it is positively skewed and when it is negatively skewed. You have already studied the skewness and kurtosis. So the mean of the distribution increases as n increases with p held constant. So if you are keeping p, the probability, as a constant, and then if you are increasing n, the mean of the distribution will also increase, because you know the mean is p into n. So if P is held constant and you are increasing n, then your mean will be increasing. Then the variance of binomial distribution is always less than its mean. Why? Why it will be less than mean? Because the variance is NPQ. NPQ and mean is NP. So if at the most what will happen, P and Q will be equal if they are 0.5. So this variance will be always less than its mean. Variance will always be less than its mean. So this point also you have to remember, because this will be asked in your examination in objective, or you can be asked to write the properties of binomial distribution. So with this I am ending the first lecture on probability distribution. Here in this lecture we have studied about the random variable, about different types of probability distribution, what is probability distribution, and among different type of probability distribution we have studied the first probability distribution, that is binomial distribution, which is used for the discrete data, discrete variables. In next class we will be studying about the Poisson distribution. Thank you.